All right, welcome AP Calc. Let's do this. So, what were the three conditions necessary to apply the intermediate value theorem? We got to make sure three things suffice. F of x must be a continuous function from the interval of a to b. F of a cannot equal f of b. And f of c must be between f of a and f of b such that this inequality holds. So we did this question in class, but what I'll do is I'll just review it again. If you want to skip it, that's on you, but I suggest everybody... Actually, no, don't skip it. Let's just watch it again. Okay, so let's have this function. You see, before we get into this, you have to be able to create a visual of what's happening here. It's saying, let's say we have this function, x squared plus x minus 1. So what do we know about this function? So for part one, it's continuous. And how do we know that this is continuous? All polynomials are continuous functions, are continuous. Okay. Let's see the next part. You see here it's saying, does there exist a value of c within the interval of 0 to 5 such that f of c is 1? So let's just draw what is happening. Here, if we have the coordinate system, okay, what is this point? It's saying that between this interval from 0 to 5. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Okay. Here, does there exist a value such that, and here this f of c equals 1, f of c equals 1, this is the horizontal line just like this. Oh, sorry. I just banged my head on this thing, but okay. So it's f of c equals 1. Now here, how do we know where the points are? So here, if I have 0 to 5, you see, this is my A and this is my B. So this is my A and this is my B. So let's plug in 0 into this function. So what happens if I have f of 0? What is that equal to? It is 0 squared plus 0 minus 1. And that's equal to, take your time, but that's equal to minus 1. So f of 0 is minus 1. And what about over here, if I have f of 5 is equal to, well, we're putting 5 into this, right? So it's 5 squared plus 5 minus 1, and that's equal to 29. Okay, so if I have f of 5 equals 29, well, let's just see, where are these 2 points? Remember, this represents the point 0 and negative 1. This represents the point 529. Okay, so where are these 2 points? This point over here, this one over here has to be like here. I'm sorry, 0, negative 1 is here. I'm sorry. And what's the other point? 529. It's somewhere up here. So notice, does there exist a value of c? A value of c is just another way of saying an x value. Is there an x value? A c. Is there an x value such that it has to, you'll get 1 when you plug in that c value? Yes, because here the idea is, you know that this graph is continuous, so it has to go over this line. So what this does is, you see, this is the visual of what is happening here. Let's say you don't have a visual, right? No picture, but you have this function. So let's take a look. Part 1. Let's try and let's see what happens here if we can use the intermediate value theorem. Part 1. F of x must be a continuous function from a to b. So is this function continuous? Yes. The function is continuous because all polynomials are continuous. Okay, let's see part 2. Part 2, we already did that. Here, if I have the interval from 0 to 5, here, what is f of 0 and what is f of 5? We just did that before. This was negative 1 and this was 29. notice that f of 0 does not equal f of 5. Okay? So we satisfied the second condition. So this is a check, this is check. Now let's do the third part. Let's take a look. Here, f of c must be between f of a and f of b. So here, what is f of c? Notice that your f of c is 1. So let's put everything into the inequality, and just remember that this is your a, this is your b, that's your c, right? Okay, so here you have f of 0 is less than, well, actually we could start it off like this. F of a is less than f of c, which is less than f of b, right? You should always set it up like this. Well, this is our a, so f of 0, is it less than f of 0? This is f of c, and this is less than f of 5. And notice, is that true? Is negative 1, is 1, you see f of c is 1, right? Is 1 between negative 1 and 29, and this inequality is true. So once these three things are satisfied, then you're allowed to say that because of the intermediate value theorem, there exists at least one number c within a and b such that f of c equals k. And this example, our f of c was equal to 1, right? Now the next question we have over here, which gets a little bit better, it's saying, okay, you're saying there exists, let me draw the picture again. You're saying that there exists a value, there is an x value between 0 and 5, such that when you plug it in, you get 1. This question is asking you, hey, I wrote it down over here. What this question is saying over here is, if we have the function x squared plus x minus 1, what is the x value, let's call it c, such that when you plug it in, it gives us 1. It's saying, okay, well, what is that c value? Okay? And the idea for this is, all you need to do is take this original function over here, let's put it over here. It's saying x squared plus x minus 1. It's saying, what is the value of x that when I plug it in, it gives me 1. So that's all you have to do to solve this part of the question. Now here, let's just substitute c. So c squared plus c minus 1 equals 1. Now what I want you to do is find the value of c. Okay? Take your time. Pause the video. So let's see, how do you find c? So the idea is get 0 on one side. Okay, so we're solving for a quadratic. So minus 1, so c squared plus c minus 2 equals 0. Then what do you do over here? You have to factor. So this is c plus 2, c minus 1 equals 0. Okay? And then here you say c plus 2 equals 0, c minus 1 equals 0, c equals negative 2, and c equals 1. Okay? So these are the two possible c values, but notice that it's in the interval from 0 to 5. So we want to find the number between 0 and 5, and what is that number? It's not negative 2, it's just c equals 1. So that's how you find it. And if you want to check it on the calculator just to see a visual idea of what's going on, let's plug it in. So if I have x to the second plus x minus 1, okay, oh, wait, the blur is really bad. Okay, I just messed up on that. So if I have x to the second plus x minus 1, okay, that's a graph. Now notice that's our picture over here. But let's also make our window like this because we just want to see between 0 and 5. We don't really care about anything else, just from 0 to 5. So notice it's saying, you see how over here, what is that x value that intersects with this? And it's right here, it's at 1. You see at 1, it intersects at 1. And that's the value of, of c equals 1. Okay, I realize I kind of just spent 10 minutes on these two parts, but I hope that I hope this helped. Okay, what I'll do is in the next video, I'll continue on with the lesson.